So guys, today we'll be starting off with a new chapter, which is totally based on geometry and all the questions revolving around that. So we'll pick up questions one by one, and as and when we encounter different kind of questions, I'll be telling you all the important formulas and the tips and tricks on how to approach those questions, right? So let's begin with the first question. In this question, we are given that there is a triangle ABC, right? And we are also given that AC square plus AB square is greater than BC square, and we have to compare the sum of the smallest angles of the triangle and the largest angle, right? So let's assume that in this question there can be multiple cases, right? For example, we are said that there is a triangle ABC. Now that triangle can be equilateral, isosceles, a normal triangle, whatever. So let's suppose that we have a triangle ABC, right? And this triangle is an equilateral triangle, right? So equilateral triangle means all the sides are equal. So let's suppose that the side is 5. Let's say anything, right? So if the side is 5, so all the three sides will be 5, right? Perfect. Also in equilateral triangle, the angle, each angle is 60 degrees, right? So this is 60, this is 60, and this is also 60 degree. I hope this makes complete sense, right? Now tell me one thing, what is given in the question? The question says AC square plus AB square. So what is AC square? AC square is 5 square, right? Plus. What is AB square? AB square is how much? Again 5 square. This should be greater than BC square. So this should be greater than BC square, which is 5 square. So this should be satisfied according to the given condition, right? So if we do this, so 25 plus 25 is greater than 25. So 50 is greater than 25, which is absolutely true, right? Which means this case is valid because we are satisfying this condition. That means the case which we have taken, that is completely fine, right? Now tell me one thing, we have to find the sum of the smaller two angles, right? So in a triangle there are three angles, so we have to take the sum of the smallest two angles and we have to compare that with the largest angle. But in this case all the angles are equal, so we take two angles. So two angles means 60 plus 60, right? So this is how much? 120. And what is the largest angle? The largest angle is the same, which is 60 only, right? So in this case, this part is 120 and this part is 60, right? So for this case, the answer becomes A. Right? I hope this makes sense, because if you take the smaller angles, so we take any two angles because all the angles are equal. So 60 plus 60, which is 120, and if you take the remaining one angle, which is 60, so obviously 120 is greater than 60. This part is greater than this part. That is why the answer is A. Right? Okay. So this was one possible case, for example, right? Now let's assume, let's take another case where we take a right angled triangle, right? Where we take a right angled triangle. Okay, so we are given in the question that, for example, if we take this case, right? Do you think this case is possible? Because if we take this case where the right angle triangle is at A, right? So according to the right angle triangle, this should be AB square plus AC square is equals to BC square, right? This should be the case. But we are already given in the question that AC square plus AB square is greater than BC square, not equals to, right? So basically this case is not possible. I mean, this case is not valid in our point. So we cannot take this case. But what if we take a right angle triangle, right? Which is, for example, let's say this case. So earlier, what did we do? We took A over here, right? And in that case, it was not possible. Let's assume that we take this, right? So now tell me one thing, that AC square, this is 90 degrees, right? So AC square plus AB square, right, is greater than BC square. What do you think? Is this true? AC square plus AB square. Let's say, for example, if this is 3, 4, 5, right? This is one possible case. This is a right angle triangle. This side is 3, this side is 4, and this side is 5. Absolutely fine. So, what is AC square? AC square is 5 square. Plus, what is AB square? AB square is 3 square. Is greater than, what is BC square? BC square is 4 square. So 25 plus 9, right, 34 is greater than 16. Obviously, it's completely fine. That means this case is completely valid, right? So tell me one thing now. What are the remaining angles over here? If this angle is 90, right? Let's suppose this angle is X, this angle is Y. I don't know what exactly the angles are, right? But one thing is for sure, that X plus Y will be what? 90. X plus Y will be 90 because this angle is 90 degrees. So obviously the sum of the remaining two angles will also be 90, right? So according to the given question, the sum of the smaller angles, which is how much? 90. And the largest angle, which is how much? 90. So in the second case, what we get is both the parts are equal. So we get C as the answer, right? So initially for this case, we had got A as the answer. For this case, we are getting C as the answer. Sometimes the answer is A, sometimes the answer is B. So your final answer becomes option D. I hope this should be completely fine. So basically in this question, what we had to do was that we had to take multiple cases because we were given a general triangle ABC and we had to satisfy this condition. So we can take equilateral triangle, we can take isosceles, we can take right angle triangle, whatever. So for the first case, I took an equilateral triangle, right? And I showed you that this condition is completely being satisfied, right? And in that case, we get A as the answer. Then in the second case, I took another case where we took right angle triangle, right? In which this condition is again being completely satisfied. And then I showed you that this part is equal to this part where x plus y is 90 and this angle is also 90. That means the answer is C. So sometimes the answer is A, sometimes the answer is C. So my final answer becomes D. I hope this should be absolutely fine.